So in order to simulate this filter and be able to look at how it behaves across different frequencies, we've provided some tools to help with that. So if you go back to the Okika Devices website and go to our help and support page and look at the Flex Analog application notes, the application note we're going to look at is actually a design guide. This AN316, how to generate a swept frequency signal, and you can read that on your own. But particularly what we have here is for AN316, we have these design files. So let's go ahead and download these design files. And when you download these, you'll get a zip file that you'll need to extract. And now within here, we have an Excel spreadsheet, a frequency sweep CSV file, and then this is an example for a 3-band equalizer that we have that you can run using this. But I'm just going to use this swept frequency spreadsheet in order to generate my own frequency sweep. So now that Excel is installed in this computer, we can open up the signal source frequency sweep file. And we'll enable this for editing so we can actually change what we're looking at. So the way this works is we can define the signal sweep time and the amplitude, the start frequency, and the stop frequency. So since we're filtering up beyond 10 kilohertz, we don't want to just stop there. So let's start 20 hertz and go to 20 kilohertz. Okay, now you can see that the graph is updated, and since things are going faster, we can simulate for a little less time. And there we go. We have our full sweep, and now we want to export a CSV file. So here you can see that this takes the time and takes the voltage, and we can then save this as a CSV file. And we'll call this sweep 20 hertz to 20 kHz .csv. And of course, we can only save one sheet. We're going to save only the active sheet in CSV format. Now we can close this out. Don't need to save it at this point. And here we have the sweep 20 hertz to 20 kilohertz. And we'll just verify that this file is in the correct format just by opening it up in Notepad. There it is. So once we've generated the sweep CSV file, we're going to want to add a component. So this is not a cam because this is not internal. This is a signal generator. So at this point, we take the signal generator and plug it into our input, and we'll double click on this to give us our options. So at this point, we want a signal data file, and currently this is just in the downloads folder. So we will select the file that we just generated, the 20 hertz to 20 kilohertz. Okay, no valid data points. So now we need to figure out exactly what the problem is. Well, after doing a little debugging, the issue turned out to be that within the file that I generated, I did not have enough significant digits for scientific notation. So I figured that out by first saving things off not in scientific notation and just making sure that I had enough decimal points so that every line was different, and that was not a problem, simulated without an issue. And then although the reference file that we're given only requires 4 significant digits, because I had made the simulation time shorter and meant that the sample rate was higher, and as a result there were not enough significant digits. So when I change this to 20 hertz this to 20 kilohertz. That isn't a problem. But then I changed this to a shorter simulation time. When that was done, the time interval got shorter. And then when you look at the data here, in the time column, you'll see that if you only have 4 significant digits, or 4 digits after the decimal point, I should say, then you have multiple times that are the same value, and that gets interpreted as having 0 step time, and you can't have that. You have to have unique time entries in every row. So that's what the problem was, and once you fix that, then you can go ahead and run the simulation.